Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. I will continue my video lesson for the topic electrolysis. Syllabus learning outcomes are for the 2023-25 version for both CAIE 5070 and IGCSE 0620. The learning outcomes for this lesson are: identify the products formed at the electrodes and describe the observations made during the electrolysis of molten lead to bromide, concentrated aqueous sodium chloride, dilute sulfuric acid using inert electrodes made of platinum or carbon graphite. State that metals or hydrogen are formed at the cathode and that non-metals other than hydrogen are formed at the anode. Identify the products formed at the electrodes and describe the observations made during the electrolysis of aqueous copper 2 sulfate using inert carbon graphite electrodes and when using copper electrodes. Let's begin with the identification of the products formed at the electrode and observation for these products using inert electrodes. Inert electrodes are made up of either platinum or carbon graphite. Both platinum and graphite are best choices for their usage as inert electrode. This is because they have free or mobile electrons. They do not react and have very high melting points. For lead to bromide, you should know the chemical formula of lead to bromide, which is PbBr2. Lead or Pb will carry positive charge and moves toward cathode. So this will be lead ions. They get reduced and discharged as molten lead. You see, you'll get molten lead. Molten means it's in the liquid form. You will write silvery white liquid obtained at cathode. Silvery white liquid obtained. This is cathode. And here, gain of electron takes place. At anode, you will write reddish brown fumes. You see these are reddish brown fumes. Reddish brown fumes obtained. These are of bromine. Bromine gas. And here you are getting lead solid or liquid. For all the metals in their molten state, you will just write silvery white liquid except copper and gold. For copper, you will write pink or reddish brown liquid, and for gold, it will be either yellow or golden. Bromine exists in reddish brown liquid at room temperature pressure, and it's highly volatile liquid. Due to this reason, you will obtain reddish brown fumes at anode. Sodium chloride. The formula for sodium chloride will be, as you know, NaCl. In this case, sodium ions or Na plus ions will move towards cathode and reduce or gain electrons to get discharged as silvery white sodium liquid. So this will be sodium. Solid or liquid. So at cathode, silvery white liquid obtained. You can even write silvery white solid for metals. Chloride ions will move towards anode, lose electrons or oxidized and discharge as yellow-green gas, which is Cl2. You see, this is chlorine gas. So the observation at anode will be yellowish green gas. Yellowish green gas released. You see here the products obtained are not in their normal state. This is because of high temperature, as we need to heat the ionic salts. Due to this reason, we are getting molten liquids for metals and gases at anode. Zinc iodide. The formula for zinc iodide will be ZnI2. ZnI2. In this case, zinc ion or Zn+2 ions will move towards cathode and gain electrons to get discharged as silvery white liquid. This will be zinc solid. Iodide ions will move towards anode and discharge as purple gas, which is I2. Iodine gas. So at cathode, zinc liquid, at anode, iodine gas. Dilute sulfuric acid. Now let's predict the product for the electrolysis of aqueous solutions. There will be two types of solutions in terms of concentration of the acids, alkalis, and ionic salts, that is dilute and concentrated solutions. You know that in dilute, the amount or concentration of water is high as compared to the solute present. While in case of concentrated solutions, the concentration of water is low as compared to the solute present. So we have dilute sulfuric acid here, which means the concentration of water is high as compared to the acid present. First of all, you should know both the cation and anions present or produced in the solution. The formula of sulfuric acid is H2SO4. Here there are hydrogen or H positive ions. First I will write ions. H positive or hydrogen ion, hydroxide or OH negative ion, and sulfate or SO4 minus 2 ions. Hydrogen ions will move towards cathode and reduced or gain electrons to produce hydrogen gas. This is hydrogen gas, H2 gas. You see these bubbles, these are of hydrogen gas. On the other hand, both hydroxide and sulfate ions will move towards anode, but only hydroxide ions will lose electrons or oxidized to produce oxygen gas and water. So these are the bubbles of O2 gas at anode. This is because the hydroxide ions are in high concentration as compared to sulfate ions. At cathode, H2 or hydrogen gas. So what will be the observation at cathode? You will write colorless and explosive gas. Colorless and explosive gas obtained. What about anode? You will get O2 or oxygen gas. So you write colorless and odorless gas. Colorless and odorless gas obtained. Dilute sodium hydroxide. The formula of sodium hydroxide is NaOH. So first of all, we will write the formula of sodium hydroxide. In this solution, there are sodium or Na plus ions, hydrogen or H plus ions, and OH negative ions. Dilute solution means both hydrogen and hydroxide ions are in high concentration. Therefore, you'll get hydrogen gas at cathode and oxygen gas at anode. I've already explained the observations at each electrodes. So I'm not going to write again. H2 gas cathode at anode, O2 gas. At cathode, write the observations for hydrogen gas, that is colorless and explosive gas. While at anode, you will write colorless and odorless gas for oxygen gas. Dilute sodium hydroxide. In dilute sodium chloride, we have sodium chloride solution. So you know the formula, that will be NaCl. So first, let us write the ions present in the solution. We'll have Na plus ion, H positive ion, chloride Cl negative ion, and OH negative or hydroxide ions. Dilute solution means both hydrogen and hydroxide ions are in high concentration. Therefore, the hydrogen will move towards cathode and reduce to produce hydrogen gas, while at anode, hydroxide ions will oxidize to produce oxygen gas and water. Here you will get O2 gas. These are O2, and this one is H2 gas. Cathode, H2 gas obtained at anode, O2 gas obtained. Dilute sodium bromide. You can easily predict the products obtained at each electrode. First, let's write the formula for calcium bromide, CaBr2, and the ions in the solution we have Ca plus 2, H positive, Br negative, and OH negative. So you know the products, we have H2 gas at cathode, O2 gas at anode. I'm not going to write the same statement. So the reason is same. You will write H2 gas because of high concentration of H plus ions. At anode, O2 gas because of high concentration of OH negative ions. For concentrated aqueous solutions, we can easily predict the products at each electrodes, but we have to consider this activity series. This is the activity series. You have to consider this activity series. It is also known as series of selective discharge. All cations or positive ions are in competition with hydrogen ions in solution. But the cations from potassium till aluminum will never get reduced. Potassium till aluminum never get reduced or discharged. Even when their concentration is high in the solution. Instead, hydrogen ions or above hydrogen ions will get reduced to produce hydrogen gas. H2 gas produced. This is because they are highly reactive than hydrogen ions or above hydrogen in the activity or reactivity series. Right above hydrogen in the activity series. You can even refer these statements for selective discharge. You see these statements, difficulty of discharge or ease of discharge. Difficulty of discharge, ease of discharge. You can write they have high difficulty of discharge or low ease of discharge as compared to hydrogen ions. Reverse arguments are also acceptable here. For instance, you can write hydrogen ion has high ease of discharge and low difficulty of discharge. For zinc and iron, it is zinc and iron. These will get reduced when they are in high concentration. Reduced when in high concentration. So we have simple reason that is that they have high concentration, so they will get reduced. So as compared to hydrogen ions. For anions, sulfate and nitrate ion, sulfate and nitrate ion never get reduced. O2 will be produced. O2 gas produced. Again, here you can also refer to selective discharge statement for both sulfate and nitrate ions, like they have high difficulty of discharge or low ease of discharge as compared to hydroxide ions. Chloride, bromide, and iodide ions will get oxidized only when their concentration are high in solution. Discharged when high concentration. Concentrated sodium chloride. You can easily predict the products at each electrodes. At cathode, only hydrogen is the product. This is just because sodium ions are above hydrogen in the activity series. So I will write H2 gas. First we'll write ions. We have Na plus ion, H positive, Cl negative, and OH negative. At cathode, hydrogen, because Na plus more reactive than H positive ion, or Na positive is above H positive ion in the activity series. On the other hand, chlorine gas will be produced at anode due to its high concentration. These are the bubbles of yellow-green bubbles of chlorine gas. So you write at anode chlorine gas because of high concentration of Cl negative ions as compared to OH negative ions. At cathode, the observation will be bubbles of colorless and explosive gas, while at anode there will be bubbles of light yellow gas. Chlorine is yellowish green, greenish yellow gas at room temperature and pressure, but light yellow in water solution. Concentrated nitric acid, HNO3. In case of nitric acid, you know the cations and anions in the solution. So first of all, we write the ions in the solution. We have H positive ion, we have NO3 minus ion, and OH negative ions. Here, definitely there will be hydrogen gas produced at cathode. Hydroxide or OH negative ions, as well as nitrate ions, move towards anode in the solution, but will get oxygen gas. The reason is same. Nitrate ions have low ease of discharge as compared to hydroxide ion. Again, you can also refer to the activity series for nitrate ions. So you write at cathode, then there aren't any reason at cathode we only have H2 gas obtained. You know the observations. I'm not writing the observations at this moment. At anode, I will write O2 gas because of low ease of discharge for NO3 minus ions as compared to OH negative ions. Aqueous copper 2 chloride. The formula of copper 2 chloride will be CuCl2. Here the ions are, so first we'll write the ions, the Cu plus 2, H positive, Cl negative, and OH negative. Copper ions are below hydrogen, so it will always get discharged, whether it's present in high or low concentration. So this one is copper solid. This one is copper solid. So at cathode, reddish brown solid because of high ease of discharge for Cu plus 2 ions as compared to H positive ions. At anode, it's very easy to identify the product. As you see here, the concentration of chloride ions are high. So there will be bubbles of light yellow chlorine gas, Cl2 gas. At anode, Cl2 gas because of high concentration of Cl negative ions. Now, if you look at this table, we have identified either hydrogen or metal as a product. produced at the cathode. So at cathode, metal, solid, or hydrogen gas obtained. And at anode, you will either have oxygen gas or halogens. Oxygen gas or halogen obtained. When the metal ions are in the solution, they will never get reduced because of their position in the activity series, or you can even refer to ease or difficulty of discharge. So these will never discharge or reduced because they have low ease of discharge or high difficulty of discharge. They are above hydrogen, above hydrogen in the activity series. Only these two metals get discharged, reduced, when high in concentration. Metals below hydrogen will get discharged because of their position in the activity series. Always reduced. Either dilute or concentrated. You can easily refer to low difficulty of discharge or high ease of discharge for these metals. Same concept is applicable to anions, sulfate and nitrate. When they are in high or low concentration, they will never get discharged. You can refer to either activity series or series of selective discharge for explanation. That is, they are highly reactive, low ease of discharge, high difficulty of discharge. Only these ions will get released when they are in high concentration. Oxidized when high in concentration. I've also explained the observation for both hydrogen gas and metals, like there will be bubbles of colorless and explosive gas in case of hydrogen gas. H2 gas, bubbles of explosive and colorless gas. For metals, we'll write silvery white solid for all the metals except copper and gold. Copper, reddish brown or pink solid. Reddish, brown pink solid. Gold, you write yellow solid. For oxygen gas at anode, there will be bubbles of colorless and odorless gas. Oxygen gas. Bubbles of colorless and odorless gas. So we have different observations for these gases: Br2, bromine, Cl2, chlorine, I2, iodine, chlorine, yellowish green at room temperature pressure. And in solution, it will be light yellow. Bromine, reddish brown at room temperature pressure. And in solution, it will produce orange. Iodine, we have a purple solid or fumes when it's in the gaseous state. Now, what will be the observations in case of salts or metals below hydrogen like copper 2 sulfate? Copper ions will get reduced at cathode and will deposit at or discharge as reddish brown or pink solid. So you'll write reddish brown or pink solid. What about silver? You write silvery white. Already explained. Solid. At anode, we will always get oxygen or water because sulfate never get discharged either in dilute or concentrated solution. You can refer activity series or series of selective discharge for reasoning. So you have bubbles of colorless and odorless gas. Here you see reddish brown solid deposit at cathode. Copper solid. Reddish brown copper solid. These are a copper metal and bubbles at anode. So we have oxygen gas, O2 gas at anode. Now what will happen if you will replace the graphite electrodes with copper electrodes? We have copper electrodes. These two are copper electrodes. We know that copper will deposit at cathode. This time it will gain electron and deposit directly on the cathode. Right here, Cu+2 ion will move towards cathode like this and takes up electron. As a result, cathode will gain in mass. Cathode gain in mass. The copper ions number will decrease in the solution. So in order to compensate this loss, the anode will dissolve. Decrease in mass of anode. Remember, there are other two negative ions in the solution, but they never get discharged because copper anode dissolves to release copper ions. Can you recall those negative ions? We also have sulfate, SO4 -2 and OH negative ions. Sulfate and hydroxide will remain in the solution. As a result, the solution will remain blue in color. Remain blue in color as long as Cu+2 ions are there. Now this slide shows that copper cathode increase in size because cathode gain mass. Cu plus 2 deposits. On the other hand, you'll see anode decrease in mass. Cu dissolves to release Cu plus 2 ions in the solution. Thanks for watching. Press like, give comments, and share my video. For more videos, subscribe my channel and press the bell icon.